Good morning to all. Myself Mahalakshmi, Department of Civil Engineering, PSL College of Engineering and Technology. Today we are learn about for the subject of Geotechnical Engineering. Geotechnical Engineering is the branches of civil engineering. So it is important of civil engineering and also for the different branches of civil engineering for structural engineering, transportation engineering and also environmental engineering. Geotechnical engineering is one of the importance of all civil engineering branches. So today we are discussing of the geotechnical engineering two different type. First of all, this full the basis of soil mechanics, and another one for geotechnical engineering. We are learn about for the foundation engineering. So today we are learn about only for the basis of soil mechanics only. So first of all, why we are just learning about for the civil engineering to study for the soil mechanic in geotechnical engineering. In brief, all branches of civil engineering requires an understanding of soil and how it behaves for structural engineering and transportation engineering and also environmental engineering. For structural engineering, virtually all civil engineering type of structure evenly comes into contact with soil via their foundation, bridges and office, residency building, chimney, towers, transmission lines, towers, offshore drilling, rigs, etc. Knowledge of soil mechanics is essential to ensure and the structures and properly supported. This can structural damage and failure and losses of financial losses and etc. And also for the transportation engineering, roadbed are often built of soil and roadways themselves can often pass through the mountain, cut, fill, etc. Understanding the soil mechanics can preclude problems with pavement of potholing and cracking, as well as embankment and slope of failure that can wipe out entire roadway. And also for the environmental engineers, liquid toxin and pollutants often spilled out, released inadvertently into the soil, and also landfilling of the solid waste. As a result, important question that need to be addressed for: will the pollutants remain in place or possibly be transported to the soil? If so, on what rate? Can anything be done to clean up the pollution? So that soil mechanics is important to the civil engineering. And also the origin of soil, it's also for the earth crust composed of soil and rock. The rock can be defined as the natural aggregate of minerals that are connected by strong bonding and attractive forces. Soil may be defined as unconsolidated material, sediment that deposit of solid particles that have resulted from the disintegration of rock. And also in general of sense of engineering, soil is defined as the uncemented and unaggregate materials, so that all made structures except those which float or fly are supported by natural soil or rock deposit. So soil mechanics is the branches of civil engineering, the concept of application of rocks and principle of mechanics and hydraulics to engineering problem dealing with soil. Soil is made up from four categories. So mineral material and organic material, air and water. So soil mechanics issue and fluid mechanics issue, two different types of issue will be solved into the soil mechanics for geotechnical engineering. So geotechnical engineer, that soil mechanics issue, the following question will be arrayed. So how much of soil will deform when it is located, and when load are applied, on what rate does soil deform, and how much load we apply to the soil before it's fail, and how does soil fail. So that soil mechanics issue, you can in this drawing to represent for that the soil mechanic to understanding for the stability of natural and man-made slope. This picture is only for the landslide will be the soil mechanics, the soil mechanics concept will be important to the structural engineers and also for the environmental engineers to fountain for the any type of structures, and also construction to any type of structure will be construction. The foundation is very important, and also you can the soil mechanics properties is very important to study well, and also fluid mechanics issue, how much to seepage of water into the soil, the seepage of water, and how can the fluid flow through the soil causes to the fail. So overview for the fluid mechanics issue and soil mechanics issue. So a civil engineer to study for the geotechnical engineering in soil mechanics. So overview of this is for the overview of soil composition. The composition of the soil in some other 45% of the mineral matter, and 20% of the 5% of the organic matter, and 20% of the water, and 20% of the air content present in the soil composition. And important to soil constitute in civil engineering, mineral matter and organic matter and water and air necessary to the soil compaction and root growth, and organic matter with the effect of the soil compressibility and settlement, and water will impact to the soil permeability and bearing capacity. So mineral matter influence the soil strength and stability. So next is the formation of the soil. Formation of the soil, four different types of soil will be formed into first of all the soil formation for the weathering, and also transportation and deposition. So soil formation is weathering is the two different types of classification weathering. So transported soil and also for the residual soil. So transported soil, the soil will be deformed into one place to another places, and residual soil will deform for the same places will be formed into the soil. Weathering, transportation, deposition, the product of rock weathering up to the size of gravel or curved soil, and beyond the consider the rock formation of soil to obtain may be residual or transported. Residual soil goes reaction placed direct over the another rock from which they are formed. Transported soil if they are removed from the original bedrock and redeposition somewhere. Transported soil further classified for the marine deposition, and also glacial deposition, and also lacustrine deposit and alluvial deposit. So water will be transported, the soil will also called as the alluvial soil. The wind is also transported, the soil will also called as the aeolian soil, and ice will be transported, the soil will be the glacial soil, and gravity force will be attracted to the one place to another place. The movement of the soil will be the soil is also called as the colluvial soil. So different types of formation of soil will be given. Then the factors affecting soil formation, the parent material, climate, topography, time, and biological activity. Some other factors will be affecting for the soil formation. So example for the parent material determine the soil mineral composition. Climate will be changes for the temperature and rainfall influence the weathering and organic activity. Topography will affect for the drainage and erosion, and time will be increasing the older the soil or more developed. Biological activity, organism contribute to organic matter and nutrient cycles. So next important topic, the civil engineering, we know that for the index properties of soil. So index properties of soil very more important for the three different types, one for shear strength and another one for compressibility and permeability, very important to concept to any other any other type of structural construction or any other work we will be going to on the soil related, the following three different type of properties will be very important. And also today we are only discussing about for the relationship between degree of saturation and water content and specific gravity, relationship between some other dry unit and dry void ratio and specific gravity, and also water content, and also degree of saturation and unit three-phase diagram, and also some other problem will be discussing on today's section. Relationship between degree of saturation and also for the gravity. So degree of saturation means volume of water to the ratio between volume of water to the volume of voids, and volume of voids ratio already know that for the volume of voids to the volume of solids, and water content for the volume of weight of water to the weight of solids. So specific gravity. So all we are the relation between the degree of saturation, void ratio and weight of water content and also physicality. The equation will be formed to the SE equal to W into G. That equation to be used for the problems. And two different types of soil will be very important. One is cohesive soil and another one is for cohesionless soil. So cohesive soil, the soil which absorb water and having the particle subtraction such that it deforms plastically at varying water content are known as cohesive soil. Example for clay, sand, plastic, silt and clay. And cohesionless soil will be for the soil is composed of bulky grain and cohesionless soil. Its plasticity effect is insignificant. Example for non-plastic silt and sand gravel. Three-phase relationship is very important in soil mechanics. So that three-phase relationship, the simple to be used for the comma B for the denoted for the bulk unit weight of soil, and comma W it used for the unit weight of water, and comma D for the dry unit weight of soil, and comma sub is the submerged unit weight of soil, and comma saturation equal to saturation unit weight of soil. This is for the three-phase diagram. So three different types of phases into the system. So one is the solid system, and another one is the liquid system, and another one is the air or gaseous phase. So three different types of phase. The relationship should be used for the soil mechanics problems in between the volume and weight relationship should be used. So next the three-phase system, the diagrammatic represent for the different phases in soil mass is called the phase diagram. The soil mass in the general in three-phase system complete the solid, liquid and gas matter. The void space between the soil grain is filled. The void space is soil place is filled partially with water and partially filled with air. However, if we take the dry soil, the voids are filled with air only in case of perfectly saturated soil. A void filled with completely water will be for the partially saturated soil. So three-phase diagram, the soil can be classified the system in this diagrammatic representation, and volume relation as the amount of both water and air are variable. The volume of solid is taken as the reference quantity. The several rational volumetric quantity may be defined. The following basic of weight and volume relationship. This one for the weight of air content, and this one for the weight of water content, and this one for weight of solid content, and total the V is denoted for the total volume of solid, water and air content. So volume of air and volume of water will be denoted for volume of voids. So VV will be denoted for volume of water and volume of air. So volume of air content and volume of water content and volume of solid content, it's also calculated for the total volume content into the three-phase system. So the total volume and total weight is also calculated for the weight of solid and weight of water. Because of the air content will be negotiated. So total volume is also calculated, volume of solids and volume of voids. It's also the volume of air content, it's also calculated. So weight and volume relationship, there are three volumetric ratio that are very useful in geotechnical engineering, and this can be determined directly from the phase diagram. So some other properties is very important to the index properties is very important to the geotechnical engineering in soil mechanics. First of all, in the voids ratio. So voids ratio of soil sample is defined as the ratio of the volume of voids to the volume of solids. The symbol is denoted for E, and E is equal to VB by Vs. VB is denoted for volume of voids and Vs is denoted for the volume of solids. So it is previous of the three phase relationship is included for that voids ratio concept. And porosity is the number of soil sample is defined as the ratio of volume of voids the sample to the total volume of soil is expressed as a percentage, and the porosity is denoted for the eta equal to VB by VT. So unit weight is the concept of the weight of soil per unit volume. There are several commonly unit weight can be used: total unit weight, dry unit weight, saturated unit weight, and unit weight of soil solids. These all formula should be included for the soil properties can be calculated to be used. So total unit weight, the symbol to be used for the comma equal to weight by volume, and dry unit weight, the symbol used for dry comma D equal to weight of solid will be considered and total volume, and saturated unit weight comma saturation equal to weight of water content, saturation water content, and also for the total volume. And unit weight of soil also calculated weight of solids divided by the total volume of solids. Degree of saturation is very important to the concept of the index properties. So degree of saturation is defined as the ratio of the volume of water to the volume of solids. So degree of saturation S equal to volume of water divided by the volume of voids into 100%. The percentage will be expressed as the degree of saturation. Next is the porosity and also the voids ratio relationship between if the porosity, the value of the porosity is expressed for the eta equal to eta minus volume of voids to the volume of solid into 100, and voids ratio also for the E equal to eta divided by eta minus 1. So voids ratio and porosity interrelationship between the soil properties. So that formula should be including for the E equal to eta divided by 1 minus 1. It's also for the voids ratio can be calculated, and porosity N equal to E divided by 1 plus E, it's also calculated for the porosity. So interrelationship between porosity and voids ratio can be calculated. Another very useful concept of geotechnical engineering is the density, which is expressed as mass per unit volume. There are several commonly used density: total density, dry density, saturated density, and density of solids. Density is also calculated for mass per volume. So total density also calculated that simple to be used for rho. So rho equal to mass per volume. It's also calculated for the density, and dry density to be used for the rho d. And saturated density should be used for the rho saturation. So mass of saturation divided by total volume, and density of solids is also calculated rho S equal to mass of solid divided by volume of solids. So that formula should be used for the problems. And next another important properties for the specific gravity. So the specific gravity, which is defined as the ratio of unit weight of given material to the unit weight of water. The specific gravity of mass of soil including for the air, water, and solid in terms of bulk specific gravity. So it is expressed as GM. So GM equal to comma divided by comma W equal to rho G divided by rho W G. Then the specific gravity of solids is denoted for GS excluding air and water. It is expressed as GS equal to comma S divided by comma W. So rho S G divided by rho W G equal to rho S divided by rho W. It can be used for the specific gravity, should be used for the standardization value, should be used for sand, clay, and rock, some other brick, some other standardization value should be used for problems. In this table for the specific gravity, Indian standardization, sand, it's also the 2.5 0.65 to 2.67. That value should be used for the specific gravity. Uncertainty sand is the value of specific gravity 2.67 to 2.70, and inorganic clay 2.7 to 2.8, and soil and mica 2.75 to 3, and organic soil will be less than 2. That value for the Indian standardization value unified classification system of the soil. This is for the relationship among for the unit weight, void ratio, and water content and specific gravity. So the relationship also calculated. The final formula it can be used for comma saturation. Comma saturation equal to G, specific gravity, plus void ratio into unit weight of water divided by 1 plus A. That formula can be used for the future use. And this the example for the problem, it can be find out for the properties value. This example, a soil has the void ratio 0.72, the moisture content 12%, and specific gravity 2.72. Determine is dry unit weight, moist unit weight, and the amount of third one for amount of water to be added per meter square to make it saturated, and also used for unit weight of water is 9.81 kilonewton per meter cube. So that example problem should be used for the following. Before the relationship should be the formula, it can be used for that example. So to be find out for the dry unit weight. So the dry unit weight, the formula it can be used for specific gravity into unit weight of water divided by 1 plus U. Already know that for the specific gravity in your problems 2.72 into unit weight of water, it can be used for the 9.81 standardization value, and also divided by 1 plus E value for void ratio value 0.72. So can be calculated the value of 15.51 kilonewton per meter square, and second one can be calculated for the moist unit weight. So moist unit weight, the formula can be used for the unit weight divided equal dry unit weight into 1 plus water content. So 1 plus water content into 15 point, already find it for the 15.51 is the dry unit weight, can be calculated the value of moist unit weight 17.38. Amount of water to be added in cubic meter of soil equal dry unit weight into water content, so can be calculated 1.861 kilonewton. So another problem will be calculated for dry unit weight, void ratio, porosity, degree of saturation. All are the index proportion relationship can be used. So that problem for the moist unit weight of soil is 19.2 kilonewton per meter cube, given that GS 2.69 and water content 9.8%. Determine the dry unit weight, void ratio, porosity, and degree of saturation. First of all, the dry unit weight, already know that the formula for can be used for unit weight divided by 1 plus water content. In your problems is given for the unit weight 19.2 kilonewton per meter cube, and also divided by 1 plus W for the water content. So water content is also 9.81. The percentage will be converted into the divided by 100 can be given that. So also calculated for the value of 17.5 is also calculated for the dry unit weight, and dry unit weight equal to 17.5. So another formula can be used for GS comma W divided by 1 plus E. So that value can be calculated for the void ratio. So the void ratio only given that 0.51, and third one for the porosity. The porosity, the formula can be used for the E divided by 1 plus E. Porosity already know that for the volume of solid to the volume of voids. So another formula can be used for E divided by 1 plus E. So already find it for the void ratio 0.51. So 0.51 divided by 1 plus 0.51. The value of void ratio 0.338. And last one for the degree of saturation. So degree of saturation of soil, the formula can be used water content into specific gravity divided by void ratio. So water content already know that for the 9.81 that value should be used for the percentage including. specific gravity 2.69 divided by Voigt's ratio value should be find it into 100. The degree of saturation also they also expressed as the percentage. So 100 will be added. So the value also calculated 51.7 percentage. Next another topic for the soil water. Next another topic for soil water. Soil water. Soil water means for water present in the voids of soil mass is called as soil water. Various form of soil water. So various for the soil water can be classified for the in several ways. Free water, gravitational water and held water, structural water, capillary water and absorbed water. So free water means water that is free to move through a soil mass under the influence of gravity of rocks in water. It also can be easily to move for the water content. So flow passage is called it easily to freely in the pores of the soil under the influence of the gravity. It's also called as the free water. Then next for the held water. So the held water, the parts of water held in soil, pores some force exiting within the pores. So that is thus the cannot move free under gravitational force. That water is also called as the held water. And another next for the classification for the structural water. So structural water is the water chemically combined in the crystal structure of soil minerals and can be removed only breaking the structures. That water is also the structural water. And also absorbed water. So absorbed water comprise the hydroscopic water and also flame water. That water is also the flame like structures. So that water is also is absorbed water. And another one is called hydroscopic water. So hydroscopic water is that the water which is the soil particles freely moisture which form atmosphere by the physical force of attraction and held in the forces of adhesions. So flame moisture is attached to the surface. The particles are a flame on a layer of hydroscopic flame which is also held by the molecular forces. That water is the hydroscopic water. And another one is for the capillary water. It is that the water which is lifted by the surface tension above the free ground surface. Water is in suspended condition. Capillary water files after the forces of soil certain distance above the water table. This distance being known as the zone of capillary water. So this is for the absorbed water, structural water, permeability. So the next topic for the important topic and important properties of soil, it's also a permeability. So permeability of the soil is property which describes the quantitative is easy to with the soil allows water to flow through it. So more is the permeability, the more is the easy with water can flow through the soil. So permeability of soil in different for the gravel is greater than of the sand and also greater than silt and clay. So that only the concept of permeability. The permeability is the seepage of water is the flow through it. So permeability concept. Why we are important of permeability in the soil mechanic? It's very important for the civil engineering for the excavation of open cut in sand below the water table, seepage through the earth embankment dam, subgrade drainage and rate of consolidation of compressible soil. So permeability concept important law should be used for. One is the Darcy law. So the soil mechanic father of Desagi should be used for the Darcy law principle applicable to be used for permeability of soil. So Darcy law, the discharge that law explained for the discharge or rate of flow per unit time is proportional to the hydraulic gradient. So velocity of flow of water, that symbol of V. So V proportionality, it's I also. V proportionality I. So V proportional I, V equal to coefficients of constant can be used. V equal to Ki. So Q equal to VA. Already know that the rate of flow, the symbol to be used for Q. So Q equal to VA. So V equal to Q by A. So Q equal to KIA. That the Q equal to KIA, it can be used for the all permeability can be calculated. So Q is the discharge per unit time. So A is the total cross sectional area and I is the hydraulic gradient, and also hydraulic gradient equal to del H by L. So del H by L. So K is the Darcy coefficients of permeability and V is the velocity of flow. So Q equal to Ka is the Darcy law principle can be used for the to be find out for the permeability. So next the factors affecting permeability. The following important affecting properties of soil. First one is the particle size, second one for the properties of pore fluid and voids ratio of soil, fourth one for the shape of the particles and structure of soil mass, another one for degree of saturation and absorbed water and impurities in water. All are the effect of permeabilities in soil. So the seepage of flow through water, the following factors will be affect the permeability. The permeability also can be tested in two different types of tests can be used for permeability concept. So the permeability test only for the laboratory test and field permeability test can be classified for the two different type of test calculated for the permeability. First one for the constant head permeability, another one for the falling head permeability. In constant head permeability test, water flow from the overhead tank consisting three tube, inlet tube and outlet tube. Inlet tube and outlet tube, the picture is not mentioned in that slide. So the three different types of tube can be used for the constant head permeability. One is overflow tube, another one is inlet tube and outlet tube. The constant hydraulic gradient I can be, the flow is the head H divided by the length of the sample. So the length of the sample is large, the head loss over the length of the specimen is measured. In setting the piezometric tube, when steady state flow is reached, the total quantity of water Q and time is collected the measuring jar. So the constant head permeability, the permeability Torsion principle can be used for Q equal to KIA. So I equal to del H by L, already use it. I equal to del H by already use that formula. So constant head permeability, the permeability can be calculated. The formula can be used for K equal to QL ATH. Thus another formula can be used for permeability test, falling head permeability test. The constant head permeability test is used for coarse grained soil only, where the reasonable discharge can be collected in a given time. However, the falling head test is used for the relatively less permeable soil, where the discharge is small. Falling head permeability test procedure, a standpipe of known cross sectional area and a fitted over the permeometer and water is allowed to down the water level in the standpipe constantly falls as water flow observation or started after steady state flow has reached the level at time t equal to the difference in the water level in the standpipe in the bottom tank. Let H1 and H2 be head at the time interval time T1 and T2 respectively. Let H be the head at any intermediate time interval and TH is the change in the head in the smaller time interval. So that formula can be used for the falling head permeability test. K equal to 2.3 AL by AT log 10 H1 by H2. That formula it can be calculated for falling head permeability. Can be used, that not mentioned in this slide, but the constant head permeability and falling head permeability test procedure can be calculated for the permeability. So that one problem will be solved of that. Example for the constant head permeability test was carried out on the sandy soil sample of 160 mm in length and 6000 mm square in cross sectional area. The porosity was 40% under a constant head of 300 mm. A discharge was found to be 45 into 10 to the power 3 millimeters cube in 18 seconds. So calculate the coefficients of permeability and evaluate the discharge of velocity and seepage of velocity. Also determine the permeability of soil when the porosity is 30%. So that for that problems will be find it for the constant head permeability. The constant permeability test, the formula can be used for K equal to QL by AHT. So that formula will be arrived only for the Dorsi-law principle, can be used Q equal to KIA. So constant head permeability K equal to QL by AHT. So Q already given that in your problems 45 into 10 to the power 3 and L is the 160 mm and divided by area is already given that in your problems, and also H is the head of 300 mm and T is the time in 18 seconds. So all be calculated for the constant coefficients of permeability on constant head permeability will be calculated 0.222 mm per seconds. So and also calculated in your problems and evaluate the discharge velocity and also seepage velocity. Two different types of velocity can be calculated. One is for the theoretical velocity, another one for seepage velocity. So discharge velocity, the seepage of water flow through the soil, also calculated for the discharge velocity V equal to QA divided by A. So that the seepage of water flow through the soil, the area of cross sectional can be calculated. That velocity is also a seepage velocity. So that formula can be used for V equal to Q by A. So Q is already given that in the problems, discharge value, rate of flow value 45 into 10 to the power 3 and area of cross sectional area. So 18 into 6000 can be calculated. So discharge velocity also 0.4167 mm per seconds, and also seepage velocity it also can be calculated, the rate of flow of water into the cross sectional area. So the velocity divided by porosity. The porosity of water can be calculated in seepage. The seepage means for the flow of water into the soil. So that only for the porosity value can be included. So Vs is also a seepage velocity equal to V divided by N. The porosity value in your problems given that 40% in the porosity. So the percentage will be converted into the 0.4 and we already know that for the discharge velocity can be calculated 0.4167 divided by 0.4 equal to also calculated for the seepage velocity. So in your problem constant head permeability test, the following formula can be used, and following head permeability test the 2.3 into QL by AL by QL by, in following head permeability test, the permeability can be calculated AL by AT in the logarithmic of H1 divided by H2 can be calculated. So next the concept of effective stress concept in soil. So the pressure distribution in soil. Before we are studying about the soil, water distributed into the soil. Before and the previous slide will be learned about for the index property of soil, and after for the water load will be acting into the soil, the permeability concept should be used. So pressure force will be acting into the load, the pressure force will be acting into the soil, the effective stress concept can be used. So all we all know that in civil engineering. So effective stress concept in soil, to three different type of stress distribution in soil. One is the total stress, another one for effective stress and neutral stress. So three different type of concept can be used for the effective stress equation. So that at any plane of soil mass, the total stress or unit pressure sigma in the total load per unit area, this pressure may be due to for the self weight of the soil, overburden of the soil. Total pressure consists of the component sigma dash. Total pressure consists of the component of the sigma dash. So effective pressure, and also U is the core water pressure. So effective pressure it is the pressure transmitted from the particle through the points of contact to the soil mass above the plane. It is effective in decreasing the voids, and also for the soil mass will be decreasing the mobility, soil mass and mobility, and its shear strength. So sigma dash equal to unit weight of soil into Z, the height level. So can be calculated for the effective stress. And neutral pressure, it is the pressure transmitted to the neutral pressure. The water table is also the, so neutral pressure can be only for the pressure transmitted to the pore fluid, which is equal to the water and divided into the unit area above the plane. It does not have any measurable influence of voids ratio, shear resistance and other properties of soil. Thus it is name of neutral pressure. So the neutral pressure, the total vertical pressure at any plane is equal to the sum of effective pressure and the pore pressure, and or neutral pressure can be calculated for the sigma equal to sigma dash plus u. Sigma dash is the effective pressure and also sigma is the total stress, and also u is the neutral pressure. At any time the pore pressure is equal to the piezometric head and also times of unit weight of water. So unit weight of water is also the unit weight of height, the head level, and also the unit weight of water, piezometric head into unit weight of water. So in this effective stress in this drawing will be explained for the effective stress calculation. So Z1, Z2 is the piezometric head, the other head level, and comma 1 is the unit weight of soil. So this is one for the water table in the second portion, and unit 2 for the comma saturation. That portion will be water will be including that phase. So comma saturation equal to unit weight of soil. So water content and solid content will be included that area. Phases. So sigma equal to total stress can be calculated. So total stress can be calculated in this bottom of A. So the bottom of A equal to the pressure distributed into the Z1 and unit weight of soil. So that phase system will be transmitted to the bottom of the section. So Z1 into unit weight of water plus, and also for the Z2 into unit weight of second portions. So unit weight of second portion will be transmitted to the pressure will be the bottom of the portion. So the total stress can be calculated Z1 into comma 1 and Z2 into unit weight of second portion. So pore pressure only for the intermediate of the side. So not only for the pressure transmitted to the upper side, only transmitted the load will be load can be transmitted to the only for the bottom of the side. So Z2 only considered. So Z2 into unit weight of water only be considered, because of the that second portion will be occupied for the water content only. Your pore pressure only you should consider only for the water content. So Z2 into unit weight of water can be calculated. So third one for the is effective stress. So effective stress, you already know that for the formula can be used sigma dash equal to sigma minus u, total stress or total pressure minus pore water pressure. So the difference between the total stress and neutral stress. So sigma dash equal to Z1 into comma 1 plus Z2 into comma 2 minus of neutral pore pressure or Z2 into unit weight of water. So sigma dash equal to Z1 into comma 1 plus Z2 bracket of comma 2 minus comma W. So that concept, the effective stress calculation in stress distribution of soil can be calculated. So some other topic will be explained in other section. Thank you.